Hello class, we're about to start section 9.3, simplifying radical expressions. Now, what we're going to do here is we want to do the square roots of positive numbers. So let's pick a quick color here. I know some of you all like that purple color, so we will go with purple. It says we know that some numbers can look different but have the same value, such as 1.5. We know it's the same as 3 over 2. 4 over 6 is the same as 2/3. Negative 10 over 2 is the same as negative 5. And 35% is 0.35. We know all of these mean the same thing. This is also true of square roots. For example, find the following on your calculator. We have the square root of 45 and 3 times the square root of 5. So we'll do this on the calculator. Okay, first thing you need to do, of course, is turn it on. Then we will press second, then the x squared key to get our square root and type in 45. And that gives us this long decimal here. Now we're going to try 3, then second, the x squared, 3 square root of 5. Now we know this means 3 times the square root of 5. And then notice we give us the same exact answer. So now, we move on to this next square root. We have the square root of 3/8 and the square root of 6 over 4. So now we will go second, then the x squared key, and then we'll do a parenthesis and type in 3 divided by 8, because all of that is under the radical, and press enter. And that will give us this decimal. Now we're going to do the square root of 6. And then we will, well, you got to press this arrow button to get it from under the radical. And then we will divide it by 4, because the divided by 4 should not be under the radical. And it gives us the exact same answer. Are there any questions? Okay, so now that I have shown you all of this, you know that I'm not showing you all this for my health. You know that you're going to learn how to break these radicals up so that we would start off with this value and end up with this value here, which is a simplified form of a square root or radical. So now we come down here. We have all of these perfect squares here. Now before I give any of the answers, they may jump, because these are in a table here, like I've told you on previous videos. If they do, then what I'm going to do is just put the values in the calculator or say them. And you would just need to write this in your course pack. So 1 squared is 1, 6 squared is 36, 11 squared is 121, 2 squared is 4, 7 squared is 49, 12 squared is 144. Sometimes these 4s don't show up right. It's supposed to be 144. 3 squared is 9. 8 squared is 64. Right. 13 squared is 169. 4 squared is 16. 9 squared is 81. 14 squared is 196. 5 squared is 25. 10 squared is 100. And 15 squared is 225. Now it says the product property of the square root of a, b. It's the same thing as saying the square root of a times the square root of b. You can separate it. It says no perfect square factors inside the square root. Write the radicand as a product of a perfect square factor and another factor. Then apply the product property. Repeat as needed. Okay, now we're going to put this definition here to practical use. So let's take a look at the square root of 28. Now we know 28 is not a perfect square. I can show you that in this calculator here. We'll take the square root of 28. It gives us this long decimal that never repeats and never ends. But But what we want to do with this square root of 28, we want to take out all perfect squares from it, if there are any perfect squares. So, in 28, can you think of any perfect square that's in 28? 4. So we will break 28 up to the square root of 4 times the square root of 7. Now you don't have to put the times sign symbol in between it. Whenever you add two radicals next to each other, it's assumed to be multiplication. So what's the square root of 4? 2. So we have 2 times the square root of 7 will be our final answer. Now we come here to B. We have the square root of 80. Now the highest perfect square in 80 is 16. So we would take the square root of 16 times the square root of 5. The square root of 16 we know is 4. And we'll bring down our square root of 5. So this would be 4 times the square root of 5. Now we have the square root of 75. The highest perfect square in 75 is 25. So we have the square root of 25 times the square root of 3. The square root of 25 is 5 times the square root of 3. And that is our final answer for C. Now for D, we have the square root of 600. Now we do have a perfect square in 600 of 100. And we will be left with a square root of 6. The square root of 100 is 10 times the square root of 6. Now, we scroll on to the next page. We have the square root of A divided by B. Now, the quotient property goes like this. And I'm going to write it above here because this will jump a little bit. Yes?
For B, wouldn't you have to reduce 4?
For B. No, you already did that. When you did the square root of 16, it's no longer under the radical. Square root of 16 is just 4, not square root 4. Okay. All right. Now going back to the next page, the quotient property, this breaks down to the square root of A all over the square root of B. Now you're going to write that here. So this would be the square root of A divided by the square root of B. Now, let's go down here to A. We want to break this up. This will give us the square root of 5 over the square root of 36. What is the square root of 36? 6. So our final answer would be the square root of 5 over 6. Now we go here to B. We can break this up. This will give us the square root of 10 over the square root of 64. So we will have the square root of 10 in our numerator, and the square root of 64 we know is 8. Now, one other thing I want to say to you all that I did to say before we did B. You know, if we would have just did the fraction first, we could have simplified 10 and 64, but I don't think that would have done pretty good here. Because if we would have simplified this, we wouldn't have 8 as the whole number in our denominator. So before you simplify, make sure whether or not this is a perfect square or not. Does everyone follow that? Okay, now with C, we had the square root of 15 over the square root of 27. Neither one of these are perfect squares, right? But we can simplify this. We can simplify this by dividing both by 3. So this would be the square root of 5 9, still under the square root. So now, we can separate this. This would be the square root of 5 over the square root of 9. So this will give us the square root of 5 over 3. Does everyone follow that? All right, now, scroll on to the next page. Now, with number 3, it says no square roots in the denominator. Rationalize the denominator by multiplying by the smallest factor that will create a perfect square under the radical in the denominator. Okay, so now, let's take a look at this. With A, we had a square root of 7. We know there's no perfect square in the square root of 7 except for 1, right? and there's no point in taking the square root of 1. So what we need to do is this here. We can multiply the numerator and denominator by the square root of 7, because we know anything except 0 divided by itself is 1. So we're technically not changing the problem. So this would give us 4 times the square root of 7 all over the square root of 49. What's the square root of 49? It's 7. So our final answer is 4 times the square root of 7 all over 7. Okay, now we come here to B. We had a square root of 2/5. So we can make this the square root of 2 over the square root of 5. Now we know 5 does not have a perfect square in it, so we'll multiply the numerator and denominator by the square root of 5. Square root of 2 times square root of 5 is the square root of 10. Square root of 5 times the square root of 5 is the square root of 25. So this would give us the square root of 10 all over 5. Are there any questions? Now, one other thing before we go on to C. If you notice, when you take the square root and multiply it by the same square root, you end up getting the number under the square root without the radical sign. Square root of 7 and square root of 7 end up becoming 7, right? Square root of 5 and square root of 5 end up becoming 5, correct? So you could just drop the square root sign. Okay, now, we have this negative on the outside. So we know at the end of our problem, our answer is going to be negative. So we could just disregard the negative sign for right now. So we have the square root of 7 over the square root of 12. Now we know the square root of 12 has a perfect square in it. We know 4 is a perfect square. So this would give us the square root of 7 over 2 times the square root of 3. Now here's the problem with this. We cannot have a square root in our denominator, correct? So we got to get rid of the square root of 3. So we will multiply the numerator and denominator by the square root of 3. Square root of 7 times square root of 3, we know is the square root of 21. Now, the square root of 3 and the square root of 3, remember how I told you that it would just be 3, right? But this will end up being 2 times 3. And what's 2 times 3? 6. So we have the square root of 21 over 6. That would be the final answer for C. Now we come here to D. Now 9 and 32, they have nothing. This is supposed to be negative. Remember, we have to bring that negative sign down. So it'll be the negative square root of 21 over 6. Got to correct that. Okay, now D. We can break this up. This will give us square root of 9 over the square root of 32. Now we know the square root of 9 is 3 because that is a perfect square. But the square root of 32, we do have a perfect square in there with 16. So it'll be square root of 16 times the square root of 2. So this will give us 3 over the square root of 16 is 4 times the square root of 2. Now, what we need to do here is we need to get rid of the square root of 2. So we'll multiply our numerator and denominator by the square root of 2. So this will give us 3 times the square root of 2 all over. This would be 4 times the square root of 2 times the square root of 2 will give us 2. So now, our denominator, we will have 4 times 2. So this will give us 3 square root of 2 all over 8. Are there any questions on D? So everybody's okay with D. Okay, now, go on to the next page. It says, recall, we can simplify a quotient containing a binomial and a monomial by distributing the division. So it'll be 15x over 3 plus 12 over 3. And we know 15 divided by 3 is 5, so that'll be 5x plus 4. Now we move on down here.